we are working on section 10.3, which is to solve quadratic equations by graphing. Back in chapter 9, we solved by factoring. When we had an equation, a quadratic equation, we set each of the factors equal to 0, and we came up with our x's being equal to 5 and 1. We knew that those were the solutions to our equation. We did that by factoring. In chapter 10, we are going to be solving by graphing this time. And you're graphing the quadratic equation. And mind you, these are the exact same two equations. But when you graph the quadratic equation, it becomes a parabola. And what you should notice about the parabola is that there are two places that it crosses the x-axis. And those two places are our x-intercepts. And they happen to be the exact same places that we got as answers when we factored. In this section, you're going to solve by graphing. You have to look for the place when y is equal to 0, those places where it crosses the x-axis. When you solve by graphing, you are first of all writing your equation in standard form. In standard form for a quadratic is ax squared plus bx plus c is equal to y. It might be equal to 0 or it might be equal to f of x. Those are all the same ideas on the right-hand side there. Don't let the notation bother you. You're doing the same thing. It's in standard form. Then you're going to graph the function by finding the vertex and using an xy table, just like we did in section 9 or 10.2. And finally, you're going to be looking at your graph to see the x-intercepts. Those are your solutions. Those are your roots. Those are also called your answers. X-intercepts, solutions, roots, answers. And sometimes they're even called the zeros. So don't be fooled when they ask you to find the zeros. They're really just finding the solutions to the quadratic equation. Your overall goal today is going to be to find the x's when y equals 0. That is your overall goal today. Let's start out in solving this equation. The first thing we need to do is get it in standard form. That means that we pull that 5 over to the left-hand side, and we will have minus 5 equals 0. We have to find the x-coordinate of the vertex. Remember, that's a negative b over 2a. So we will have a negative 4 over 2 times 1, which gives us a negative 2. So we know x equals a negative 2. When we draw our xy table, we're going to put that negative 2 right into the xy table as part of our vertex. And we'll plug the number back in, negative 2 squared plus 4 times negative 2 minus 5. We'll set that equal to y so that we're actually solving for the variable, the y. And that turns out to be 4 minus 8 minus 5 equals y. And that gives us a negative 9 for our y. That is going to put us down here at negative 2, 9. Whoops, put it in the wrong spot. Let's move it over. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, negative 2, negative 9. Then start working with numbers on the left and on the right. So we'll have negative 1 and negative 3. When you put in a negative 1, that's fairly easy math to do. Plus 4 times a negative 1 minus 5 equals y. You should end up with a negative 8 as your y. Now, if your vertex is correct, when you put the negative 3 in and square it, add 4 times the negative 3 minus 5, you should also come up with a negative 8 equals y if you've done your math correctly. Both of these y's need to be the same if you have the right vertex. If you're not coming up with the same number, one of two things is happening. Either you're doing your math wrong just in substituting your number, or your vertex is in the wrong place. Check over both of them. We have to keep moving until we find our y equal to 0. So I'm moving on to my next numbers. I can put 0 into the equation. That's a nice, easy one to do. And if I know I have the vertex in the right spot, I can reflect it and just put that answer in the other side. We're still not at our 0 yet, but let's get these in so that we can start seeing what our graph looks like. It's starting to come up. Okay, we know that we have to go a little bit farther, 1 and -5. When we put in 1 squared plus 4 times 1 minus 5 equal to y, we find out that y is equal to 0. Great, I can reflect that on the other side, and I will have a 1, 0, and a -5, 0. I can draw my graph the rest of the way through it. And then I will write my answer as x equals 1, comma, -5, because those are the two places that it's crossing the x-axis. If I write the coordinates, that would be 1, 0, and -5, 0. Those are the x-intercepts. The x-intercepts are labeled there as -5, 0, and 1, 0. The graph and the xy table are proof that we did it graphically. Your answer should be x equals 1 and -5. Does every quadratic function have 2 zeros? Absolutely not. We know that we have a quadratic that crosses the x-axis in two places. It might go this way, it might go down. Okay, we know we have two solutions. That's one we were just working on. Sometimes, though, the quadratic might just barely touch the x-axis. And when it just barely touches the x-axis, that's going to be in one point. There is only one solution. And there are times when our quadratic is above or our quadratic is below, and it will never touch the x-axis. This is when there are no solutions. Please note, it will fall into one of these three categories for you. Thank you.